So hello again, everyone. I am Michelle Munson, CEO of Eluvio, and we are a startup company that has created a new technology for content distribution at scale. It has very unique properties for premium content. It's hyper efficient. I will explain that. It's ultra fast. It allows for tamper-proof, owner-controlled distribution, and it has intrinsic monetization because it's data-driven and allows for the rights to be in the media. If after my talk you're interested in learning more, please visit us, West Hall, second level 237. I will be talking today at 1 o'clock and again tomorrow and doing a full set of demonstrations of our new Casablanca release and our new applications. In addition, we're happy to host you for meetings as well. So let's get started. The most important thing about the Content Fabric is it looks at the problems of distribution from the ground up and aims to tackle what premium content needs. High performance for 4K live streaming and premium VOD, as well as fast channels with personalized content insertion. It puts the control and security directly into the hands of the owner through the state-of-the-art encryption and content security model that is blockchain-backed. The sustainability is significant. The carbon footprint of resource usage, because of how it's designed, is much lower than traditional technologies, which reduces the costs tremendously. And then finally, it's simple, because the functions that are typically disparate across the CDN and the media cloud, like transcoding and packaging and origining and even layering in ad insertion and all of these custom functions and workflows, a lot of which are done sort of brute force at scale, those are embedded into the protocol itself. So you just use it. And then finally, it's owner controlled and tamper proof, which is very important now that we're getting into this age of AI where people are concerned not only about deep fakes, but also thinking about really being able to monetize authentic content. So with that in mind, I'm going to start by giving you a little lay of the land in the industry. Why would this be important now? It was very interesting for me. I just came off the IABM Trends Breakfast this morning. The top line problems for the industry right now are the need for greater profitability, the need to reduce costs, and the number one contributor to those costs is clouds and virtualization. The second point, after the why, I want to get into the technology overview and show you how this works, because inside it's very novel and different. It's also very powerful. And then I'm going to tell you about our new Casablanca release, which brings advanced audio and video features to the core and then also introduces new applications that allow you to extract value out of this. For example, the new Creator Studio Suite, which lets you create media properties that are literally turnkey, backed by the Fabric, and allow you to sell media directly. Also, our new Content Analytics and Visualization app, which allows you to see the Fabric performance and all the viewing statistics on your titles. And then also AI-based tagging and search, along with automatic surfacing of clips, highlights, and summarization. So with that, I'm going to get started. Oh, and one more thing, use cases. I won't have time in this talk to go into detail about our major use cases, but I do want to introduce them here so you have an idea of what they are. At the top line, premium VOD and new electronic sell-through in home entertainment. For example, our customers Warner Brothers and Paramount. Ultra-low latency secure live streaming in sports. For example, our customers Telstra and UEFA for the Euro 2024 wrist service. Sony Pictures for film and TV library servicing as a single source of truth in the Fabric, the entire SPE library. EPCR, the European Rugby Federation, for which we do many things. Currently live recording of the matches directly to VOD and also responsibility for the archive. And I'll talk to you a little bit about their phase 2 in my talk later today for OTT streaming to consumers. Attention Seekers, which is a fan engagement agency that focuses mostly on esports. And they're building an app for live event streaming with embargo capabilities directly on the Fabric. And then finally, MGM, now Amazon Studios, for their ROAR content licensing suite and also their generative AI clip generation service for clips and licensing. So first of all, the why. We're definitely sitting in a time when these 3 points are obvious to everyone. Complexity of workflows is very high. Why? Because we make workflows that basically knit together lots and lots of individual services, and that is especially true in going all the way to distribution through the CDN to the consumer. The media, the data, and data is very important now with so much generative AI, and the processing are siloed in those workflows. They are not inherently together, and we spend a lot of money and go through a lot of complexity to bring them together. And much of the scale in streaming performance occurs by brute force, spending more, deploying more resources. That brings me to the cost problem. I don't have to tell any of you, it's clear in the top line macro reports and in the individual cases that media companies are suffering from the technology spend in a time where they need ever more profitability. And then this all leads to a very entrenched situation for innovation. The architecture is stuck, therefore you can't do the things you want to do. Personalization is hard if it can be done at all. And then we now have this wonderful AI deluge that we can use to drive greater engagement in monetizable content, but we can't very well capitalize on it, at least not at large scale. We would argue that the industry needs a way out of this. And this is where technology can help. The content fabric is both an application protocol and an instantiation in a global and open network. It's open, meaning that the network can extend without limitation. It's inherently fast, meaning it's designed to allow for real-time content, low latency streaming to be served consistently everywhere on demand. It is so much simpler than the traditional architectures because it brings into the protocol so much of the guts that had to be exposed to these piecemeal workflows. The media, the metadata, and the processing are inherently together in the protocol, and they work together to produce the output on demand. Because of that, it's also hyper efficient. The same raw content can be reutilized over and over again without restoring it, repackaging it, making new file versions, and copying them around and paying all of the intermediaries that provide infrastructure and bandwidth and storage for doing that. That also allows it to scale much easier. And one very important statistic you'll see in our performance demonstrations is that 99% of segments that are served from the Fabric streaming segments, like HLS segments, serve in under 1 second, and the average is 300 milliseconds. And that's not by brute force, it's by design. It is secure and transparent because the content itself is owner-controlled and encrypted with owner keys. And any authorization is by data that's part of the certifiable version of that object. And then finally, the authorization happens just in time also. So if you want to do a new type of EST sell-through, you can put the film window into the policy. It will vary based on the client, where they're coming from in the world. You have your geo windows. You can create an access pass that's effectively a subscription or a pay-per-view instrument that user has to have under their ownership in order to have a complete media selling pipeline. That's all it takes. And then finally, it allows for data to be used on demand in the pipelines. The data's in the media. And this is such a big deal now that we have the AI extent. For one, it means that never goes unused. The second is that you're not taking big forms of video and trying to transfer them over to cloud AI services and try to get the result back and do something with it. It also means that you can utilize that data to make personalized content at the session level. There are a lot of advantages over traditional content delivery networks and pipelines. The most important, in my view, is the efficiency, but you can run through the pillars of that. much better latency. You get redundancy and scalability and linear performance by design. The content isn't being duplicated around as files. The solution cost is a lot lower, and a lot can mean 10x at scale, sometimes more than that, depending on how much you're using it. And then data-driven, personalized output is easy to do. Very little has changed in distribution. And this chart is the way that content delivery and packaging has been since 2000. I will date myself, start of my career. It's been like that. Shows you how old it is. Secondly, what about the AI data? Not only do we transcode and package and distribute this out through these edge caches and keep doing the same thing over and over again, where there's a lot of duplicate content and we can't get the lift we need. Now we add in this deluge of data to this. How are we going to take advantage of that? And this is very clear because multi-version media is the backbone of everything we do in VOD, in live, and interactive, meaning that we take the same content and we make lots and lots of variants. And we understand that in terms of what's straight in front of our eyes, but we often don't understand what that means in terms of the bytes used over the network backplane, the fact that all the storage requires this, the fact that we have to compute over all of this successively, and all of that accrues in that sort of like traditional approach. A typical media workflow, especially on the cloud, typically looks like this. Media, metadata, and processing are separate. There's some aggregation of services that you're supposed to put together to bring that together. It gets even worse as you pile in more and more data, and you pay for all of this all the time. So the Fabric Protocol approaches this differently. It says, let's make this content native from the start, and then let's make it so the media and the metadata can be acted upon when needed with processing that's in place. It also is built so that we do not spend time making files unnecessarily, and we pipeline all of our operations over the network as we're doing this. And then finally, when we do it, we encrypt the content for the owner, and we have express versions that are tamper-proof, so we know the state of the content, and authorization is tied to that encryption and re-encryption, including standard DRM. This is what we call application layer solution. It sits between TCP/IP and the media applications on top. What's really important is what comes in as media source never changes. Master files, live streams, standard formats, images, data, and what comes out is standard. HLS, dash, file downloads, playable content, images, watermarked content, you name it. HTML apps, all of the above. I'm going to show you a little of the technology. I'm not going to go too deep. After all, this is a commercial show, but there's a few key ideas. Idea one is that instead of representing media as just bytes, like we do in files, in the protocol, it gets represented as a component-based object. What's really powerful about that is that object can represent anything. The parts of the object can be media, they can be code, and they can also be data. The second key idea is when the object changes, only the changed parts update by reference. And then finally, you can get a certifiable fingerprint or hash across the bytes of that object so you know what it is. And because those bytes cover the code, the traits, and the metadata, not just the media, you can certify the output, not just the raw stuff. And then finally, that hash gets committed in the protocol into its ledger. The Fabric pipeline produces outputs on demand. So all the streams you're going to see up in our meeting room coming out of the Fabric, live streams come in, and ABR streaming content comes out. But it happens to be built on demand when the user makes the request for a URL. This is very powerful because we're not doing anything that we don't have to do, saving tons of resources. And this turns into a global protocol because it's infinitely extensible. happens to run over nodes that are spread around 15 locations in the world today and has the capability to be extended without limit. Finally, the policies inside of these objects actually let you put the rights data directly as part of this. It's like you said, I'm going to issue a software program to make my media, and I put these rules into it. And then those get enforced through the security model. The security model authorizes every session and only re-encrypts the data to the entity that's getting the streaming or the output if authorized. And that's also under the control of strong identities. These are big problems we've had in media for a long time. It's been hard to have a common strong identity. It's been hard to have good owner protection without having put up lots of walled gardens. And finally, it's been a mess to try to enforce rights directly in place in a flexible way that doesn't cost. This way, it's all intrinsic. It doesn't cost. So what do we do with this? Ultra low latency live streaming at scale. This one of our example streams. And then when you look at how this is really happening, you have the live streaming source coming directly into the fabric. The fabric is software on nodes. Those have IP addresses. They have URLs. That points that live camera feed, whether it's RTMP or SRT or MPEG transport stream over UDP, comes direct from the venue to the fabric node. And what you'll notice about this is that that process is also automatic. And the ingest process creates parts, which are transcoded, recorded parts that make up content objects, and publishes them through this network. The way that gets done is really important to the scale, because those parts sit on nodes according to a scalable, decentralized hashing algorithm. There's a lot to that, but it allows for those to be found in real time. So if you get a client over here that needs to get some streaming segments, the client requests that URL. Those segments are not necessarily built. If they're not built, what happens is the node that got that client's request can get the parts, which are the top bit rate in this particular case, transcode those just in time, and produce both the manifest and the streaming segments. And then because this doesn't have my animation, these slides had to be static for this particular setup, you have to imagine how the part flow works. But those parts actually flow over the network without stop-offs. And if you take a look at this in a real-time pipeline, you can see when that's done correctly, there's no time spent. The only time spent is the real time of the content, the real time to transcode 2 seconds of output video, which means that you can guarantee through a global network that you're going to serve that 2-second segment of video out to any player in 2 seconds plus the propagation time for that first part. And that's where I said that the latencies, the average segment serving latencies, are 300 milliseconds. And then you can go to HLS and you can say, here, player, I'm giving you your HLS streaming content in 2 seconds plus a few hundred milliseconds. And we didn't have to brute force anything. That's the point. The other thing that's also interesting about this kind of model is you can interject other functions without degrading it or changing it up. So we integrate with NAGRA, forensic watermarking, now in live in addition to on demand. And that has a elegant algorithm that runs to determine the A/B pattern to have a unique signature on those segments for the watermark that's transcoded in. And that ends up being per session by design without changing anything at all. This means that if that stream leaks in the middle of a big live sporting event, it's detected as being leaked, and then we go back here to the content object that is this live source with all these parts, and we update the policy and say, you bad session, no longer authorized. Cut off at the source. No more chasing ISPs to figure out which thing is leaking, and furthermore, absolutely unique to that session. So I've talked a lot about the just-in-time streaming details. This is set to serve standard HLS and dash at scale, simply put. And then finally, to be able to personalize it, with dynamic functions. So let's talk about scale, and then we'll go into personalization. So we started a new test bed this year for fabric performance measurement at scale. We take nodes in a region of the fabric and point them at another region. So in this case, we took some nodes in North America and pointed them at Europe. And we used the nodes in North America to run streaming clients. We decided to set up our test bed to run 100,000 clients and then 150,000 clients. And then on the other side, for the nodes in Europe, we measure the segment serving latency. How long does it take those HLS segments to come out? And you can see here in both of those tests, the 99 percentile, which means if you take the segments to the clients and you find the 99 percentile of those, they all are under 1 second. And if you look at the average, it's at 300 milliseconds or less. Another interesting observation to the economics that we've all been told are all we can do is that the clients are not close to the servers. The clients are 50 to 80 milliseconds away, which also means that you can start to serve without so much locality. That also takes away a lot of the cost. And then finally, remember that what we're serving here is a live stream coming into the fabric. For our tests, we actually use a live stream source that comes in from Tempe, Arizona. It's an actual customer feed that we have in a test bed, and we do the streaming clients are streaming that content, meaning that it's truly global. You understand what I mean? Clients in North America, nodes serving them from Europe, stream ingesting from Arizona. That's the point. And then one more big takeaway is the fact that if you're in film and TV, the other thing you're paying for all the time is that you have to usually make lots of versions of your content and store them and move them around. In the fabric, you can create all of your just-in-time variants. Like this is Sony's Spider-Man in the fabric. There are 90 different variants of that object due to all the language dubs that Sony distributes. All of them are served from one content object. Okay, the guys told me I have 5 minutes left, so I have to move faster. Okay, this is really interesting. So everybody knows about fast channels and how rapidly the industry has moved to try to ad monetize. One of the things that, and we have a pilot of this upstairs running in our booth. One of the things that's very hard to do in these is to get real engagement. For lots of reasons, technical reasons, content reasons. So a contributing factor from the fabric to help this is that you can easily personalize the content. It's low cost, frame accurate, and you can do whatever you want. So our personalized weather demo inserts personalized ads for users in 3 different regions. It's not doing it bespoke. Instead, it's using fabric code functions. So what happens is, in this case, you can have a live stream source like Fox Weather coming into the fabric in real time. Then you can have ad content, in this case, in the fabric, could also be external, and an API that adds metadata to this stream that calls a bitcode function. It's part of that object. Got an object with some code. And that code is written to decide some business-specific policy. In this case, the code binds the ad content by its tags, which is also a content object, to the user groups, each of which is distinguished by their session authorization tokens and, in turn, their IDs. So now we have a way that we can give the Los Angeles user LA-specific ads. We can give the Phoenix user Phoenix-specific ads, and the Washington, D.C. user DC-specific ads, and we can also multiplex that by what the content is, and we didn't have to go and build a whole custom vertical solution again and spend a lot of money to do that. And finally, let's imagine that we decide we want to do a different kind of personalization. The archive team comes along and says, we would like to create a curated archive channel where what you get in historical moments is based on what you say you like. Well, a different sequence plays out for each of the users. Same idea, same technology. I need to wrap up, so I want to just say this. The last bit here is that the fabric is a great environment for tagging content with machine learning, AI, and particularly highly descriptive generative models. And we have built out a tagger service that does just this. Those tags live in the object, and they are time-coded, so they're synchronized with the audio and video. And then they're indexed by the Fabric search so that they're actionable to do things like doing those content insertions or surfacing a clip that's just a start and an end offset played out just in time. This gives a huge amount of power in our applications, and that pipeline is very low cost. The content never moves, the tagger runs on it, the tags stay with the object, the search service indexes that, and then all the dynamic functions can be surfaced directly out of it. And then finally, for a little more visual, you can build things that allow you to surface clips without touching the content. Imagine a live game that's automatically recorded, no file copy to make the VOD, and then it's tagged, and then it's indexed, and then the clips can be found, and all of that can happen in 24 hours. Never human touch. You can also get semantic descriptions out of this. And then finally, we have tools, and we have a video editor that we have created that allows you to step through and view those tags, create clips, and export. And then finally, you can turn this to the consumer. And we have created a wallet application. Obviously, this works for standard players, but we've also created a wallet application for TVs and browser that allows you to have turnkey properties that you can directly monetize. And we're showing a new application for creating these sites called Creator Studio here. I invite you all to come up and see us. I have a lot of use cases, which I will not be able to go through in this talk, but you will come and see me. You can see what I have. And I will wrap it up here. Sunday afternoon, that would be in 1 hour, talking upstairs, and again tomorrow. Thank you all.